Hello friends. In last video we talked about type safety and bounded types. If the video was useful, please subscribe to my channel and press like button to encourage me making more videos. Type safety is very important feature, but sometimes it may make some difficulties. For example, given the calculation in last video, assume that you want to add a method called hasSameAverage that determines if two objects has same average, no matter what type they are. One way to implement hasSameAverage is to pass it a calculation argument and then compare the average of that argument against the invoking object, returning true only if the average are the same. It seems that it's very easy because calculation is generic and its average method can work on any type of calculation object. It seems that creating hasSameAverage would be easy. But the problem starts as soon as you try to declare a parameter of type calculation. Let's see an example. Here the problem is that it will work only with other calculation objects whose type is the same as the invoking object. For example, if the invoking object is of type integer, then the parameter object must also integer. It can't be used to compare the average of an object of type double with the average of an object of type integer. So this approach won't work except in a very narrow context and does not yield a general solution. To create a generic has same average method, we should use wildcard argument feature of Java generics. The wildcard argument is specified by the question mark and it represents an unknown type. Using a wildcard, here is one way to write the hasSameAverage method, allowing any two objects to have their averages compared. It is important to understand that the wildcard does not affect what type of calculation objects can be created. This is governed by the extends clause in the calculation declaration. The wildcard simply matches any valid calculation object.